test. Okay, so we're going to do one, right? So as to help you to recap, right, how it works. This particular question. So Fruitera have 48 kilograms of fresh plums. The plums contain 70% water when fresh. Okay, so 10 days later, there was only 60% water. What's the mass 10 days later? Right, so you see, so there's 70% of water. So we get water and then flash, right? It's either water or flash. You understand? Right? Just these two things. At first, when it's fresh, there's 70%. Then here must be 30%. You got it? 70, 30 ma. 10 days later, there was only 60%. So if this is 60%, then this must be 40. All right? Now, the question you got to ask yourself here is, does the mass decrease or does the water level decrease? Will the flesh disappear if nobody eat it? No, right? But the water will evaporate, right? You know what I mean? So the water is the one that is gone. So this one should be the same, right? This part should be the same. Okay, so here to minus some, but I do not know minus how much. Okay, all right, I don't know how much, but this should be the same. So let's take a look. This is 30%. Now 30% means 30% of this, right? 30% of 48 kilogram. What is 30% of 48 kilogram? We take 30. Okay, I'm gonna need some more space. 30 over 100 times 48. What do you get? 30 over 100 times 48. Borrow a calculator. $14.4. Right, so here is 14.4 kilogram. Okay, that means afterwards, it should still be 14.4 kilogram because the mass did not change. Got it? The flesh did not change. I still need this. All right, so if this doesn't change, actually we can, you see, what was the mass of the plums 10 days later? What's the mass of the plum 10 days later? And then 30% water when fresh. 10 days later, there was 60% water left. What was the mass 10 days later? Okay, so you see, this is 14.4, right? And 14.4 now represents 4 units. Okay, the mass includes this whole thing, which is 10 units. So to find the mass, we take 14.4 divided by 4 times 10, right? Which will give us 4 times 10, 36. Oh man, okay, the answer is 36. Better switch off the video. Right, every time I switch on the video, the whole thing gets jammed. Okay, so we get 36 here, right? You get the idea? Yeah, gone. 36 kilogram. Okay, because this thing doesn't change. We need to understand the fact that this thing doesn't change. So this is 4. 1/4 is 4. All right, and then I can find the total mass, which includes the water and the flesh. You got it? So it's not really like a before and after, right? But there's a bit of a twist. Right, there's a bit of a twist over here. Next. Okay. Is this okay? Can I go to the next one? I don't know if you got 36, right? It's a bit weird, this question, right? To be honest. Next one, we look at 4. Let's look at 4. So rose syrup and water were used in the ratio 1:3. So rose syrup and water 1:3 to make rose syrup drink. So Jennifer preferred a drink that was less sweet. She added 20 ml of water into a cup of the rose syrup drink. Then the percentage of rose syrup dropped to 20%. What does this mean? Now, that means the water changed, right? Did the rose syrup change? No. Okay, that means she diluted the rose syrup by adding 20 ml, right? Then the percent rose syrup dropped to 20%. So this became 2 and this became 8. Why 2 and 8? Because it's 20% and this is 80%. Got it? So three at first is 1:3. Okay. Can you tell the handwriting? 20 ml. At first it's 1:3. You add 20 milliliter. It became 2:8. So which one never changed? Is it the R or the W? Is it the rose syrup that never changed or the water that never changed? Which one is it? And Princeton, looking at you. Which one? Which one never changed? Which one never changed? Yeah, the rose syrup never changed. So what do I need to do? Make rose syrup the same. Okay? How do I make rose syrup the same? The top ratio must times 2. So if I multiply by 2, we get a new set of ratio, which is 2:6, right? And then here becomes 2:8. And here is plus 20 ml. Okay, so can you see now it's very clear. 2 units represents 20 ml. Right, 2 units represents 20 ml. So 1 unit is 10 ml. Okay, so how much water was there in the cup? How much water? Actually, I don't even need to find one, right? It's just 2 units. So in the cup, there were 20 ml. That's it. Easy or not? Really, really easy, then say easy, okay? If it's not easy, it doesn't matter. Okay, so we move on, right, to the next one. Question number 5. So you're saying you don't know how to do 5, is it? 5, is it so hard? Let's take a look. Anyone can do 5? Do you want to do 5? Kenny? Kristen? No? Kenny? You got answer for 5?
I don't have.
How you try? What's the answer?
20.
20. Okay. Let's check, okay? Do you have an answer? Totally nothing. Okay, so there are some oranges and lemons in the carton. So we have oranges and lemon. So if 48 more lemons are put into the carton, plus 48, the percentage of oranges will decrease from 40% to 25%. So at first here is 4:6, then it became 1:3. Okay, so this is the first table. Did you get this table? Did you get this table? Orange, lemon, at first 4:6, then it became 1:3. Okay, do you get this table? This is the first table. Do you need me to explain again how to get this table? Okay, so if I have this, then which one never change? The number of oranges, right? So if oranges never change, I can make this reset the table. In fact, I can make this 2:3, and then here is just 2:6. So this is plus 48. Okay, so from here, I can tell that 3 units is 48. So 3 units represents 48, and 1 unit is 16. Okay, 3 unit 48, 1 unit 16. So how many oranges are there in the carton? There are 2. You see, there are 2 units. So 2 units will be 32. Okay, that's it. Any questions so far? Any question? No? Right? Easy or difficult? Okay, Princeton, easy or difficult? Not easy, not difficult. Okay. So you do the next one, okay? 6, 7, 8. It's the same stuff. Once you get used to it, it's the same thing over and over again. Okay, at least for me, because I've done a lot. You all just started the before and after journey, so it's gonna, you will soon realize the same stuff.